CodeBright is a program that solves the thermo-hydromechanical equations in geological materials. Here in this video we present some new developments that are in progress and that make a big advance in the modeling capabilities of this program in the different contexts and applications we are working on. One of the things we have been doing is the incorporation of heterogeneity for the geological material. This is a very important feature, and then thanks to the incorporation of this heterogeneity we can develop different fields of properties that are spatially correlated, and we use geostatistical techniques to develop this type of applications. Thanks to this, we can solve these gas migration problems which are related with the gas generation induced by several chemical processes like corrosion or organic matter degradation, and then this gas migrates in isolation barriers which are very low permeability geological materials like clays, and then it's very important to have this capability to incorporate heterogeneity. And also, in addition to heterogeneity, if the spatial correlation is done in an adequate way and also the properties are different in different directions, this is very much related with the anisotropy. So anisotropy, which is something that we can model through the traditional constitutive equations, incorporating the trigonometry and so the directions, it can be done also in this way when the spatial correlation and the different correlation parameters are considered in different directions. And then something that appears as local isotropic, it becomes globally anisotropic, and some properties can be represented in this way. Another direction of research is related with the chemical. Chemistry is a process that we have to incorporate to the thermo-hydromechanical equations and has influence on many of the applications that we are working. For instance, in this slide I summarize the effect of salinity in the behavior of swelling of clay barriers, that when the ionic strength changes due to the presence of the saline of the salts in the solution, then that affects the swelling of this material and can reduce it, and then it can have an influence and has to be investigated.
Okay, another aspect is the implementation in the code of a procedure to capture strain localization during material softening. One application is a modeling of the so-called fractured zone around excavations in deep repositories, because this zone may be the preferential seat for gas and water flow that will carry contaminants. So the procedure is based on the non-local integration technique. That means that the value of the history variable, which is considered at the point where the stress integration is carried out, is an average value of a zone around that point, and the size of the zone is a material length scale parameter that regularizes the strain localization problem. So this technique has been implemented in elastoviscoplastic models, and this model used in simulation of real cases of excavation at high depth, around 500 meters. We can appreciate here the ability of the model to capture the shape and the orientation of the fractured zone, depending whether the gallery is excavated in the direction of the major horizontal stress, as at the top, or in the minor one, as at the bottom.
We are developing the interface with GiD for several years, and we believe that we have reached a point of sophistication thanks to the capabilities of GiD to this customization, and then in our case a big effort has been done in implementing boundary conditions that for the thermo-hydromechanical and more recently with the chemistry are sophisticated in terms of parameters, and then along the intervals these boundary conditions have to be managed first by the user and later by the program, and this is one of the things we have put a lot of effort. In terms of the GiD, we use different types of meshing, and in particular in 3 dimensions. Sometimes it's interesting, this feature of the semi-structured meshing, because it permits to work with the hexaedra, and in some of the geometries we are working, that appears to be the most adequate method.